Hi Chem students, this is Ms. Thomas.
I'm Ms. Frankovic.
And we are going to be walking you through the ideal gas law lab. We're going to be showing you how to collect the data for each of the variables, walking you through the procedure and recording the data very closely for trial 1, and then we will do 2 more sets of data for trial 2 and 3, and you'll be actually reading those data pieces and recording them. Anything
Perfect.
else? Okay, here we go. So I would recommend that you have the procedure kind of handy so you can kind of follow along. And I'm going to start here with step number 1, which says take this butane lighter and submerge it in a basin of room temperature water and press the lever. And if you kind of see that there, I don't know if you can see it in the video, it's bubbling up. This step just has to be done once to start the lab, to kind of get water down in the nooks and crannies. And then a very important step, once I take the lighter from the water, is I have to shake the excess water out of it to dry it off very well, because I don't want extra mass in my lighter. So that's step number 1. We're just doing it once to start, and now we're going to take the mass of the butane lighter and record it in the data table. So remember to zero your balance, place the butane lighter on the balance, and the first piece of data is the initial mass of butane is 21.55, and then we're going to put that grams right after the variable and not after our number. Notice I'm reading all of the digits on the balance. I'm not rounding this off. This is lab data, so we read our instrument to its full capacity. Now I'm ready to do step 3, where I'm going to take this graduated cylinder. I'm going to take the bottom off of it just to make it easier to read, and I'm going to dunk it in. Remember when you were a little kid in your bathtub playing, and you would fill up your containers with water, and what I'm banging it for is trying to get rid of the air bubbles there. It says be sure there are no air bubbles. I'm kind of failing, so I'm going to redo it there. And once we fill it with water, we invert it like this, and we have a filled tube with water. And so when I bubble the gas from this butane lighter through it, it will be, of course, less dense, and it's going to displace that water. And I'm going to get rid of that bubble that's at the top.
There it is.
And then I will be able to bubble the butane from this lighter into there, and it will displace the water in there. So this is a process known as water displacement, or collection of a gas over water.
And she's making sure that all the bubbles are going into the graduated cylinder, not on the outside at all, because if we lose some of the bubbles, that means some of our mass of butane is not going to be accounted for in that volume. You can see it going down there.
Yeah.
We're collecting about 45 milliliters, and this is a 50 milliliter graduated cylinder. So right now we're at 5. We're going all the way down here to 45 milliliters.
And an important thing that happens when you're collecting a gas this way is that you're actually not just collecting butane gas. That water vapor sitting at the top of the surface right there, based on the temperature that everything is at, has the ability to escape and exist up here with the butane gas, and that's known as water vapor pressure. And it's something that we're going to have to account for in our calculations, where we are going to have to look up the water vapor pressure at whatever temperature we read on our thermometer and make a correction to our pressure, so that we have what we call the pressure of the dry butane. Did I explain that well enough, Ms. Frankovic?
I think that was beautiful.
Okay.
So once we're done with these trials, we'll actually go over that equation with you, Dalton's law of partial pressures, so that you can see how we're accounting for it in our data table. It's just going to take a little while.
40.
Yeah.
5. And again, the exact amount you collect here actually doesn't matter. We're only going down to 45 because, butane being a gas doesn't have very big mass, and so we want a decent enough mass sample, so we kind of have to go down somewhere between 40 and 50. But it doesn't matter exactly where you stop, but you have to read your graduated cylinder exactly when you get down there. So if I don't stop right on the 45, it's like no big deal. I'm almost there.
You just can't go past the 50 milliliter mark, because we have no markings after that point.
So now we're going to be on step number 4, where we're going to, we just did step number 4, position the butane lighter and collect 45 milliliters of butane gas. we're going to do number 5 in a minute, but let's do 6 first. Where if you look at this, you can see that when I kind of raise, I don't know if you can see it well, but raise and lower the graduated cylinder, you can see the level of the water inside is lower, and if I bring it up, it's higher. Technically, when I read it, I have to make sure that they are equal, because I'm going to use the atmospheric pressure pushing down on the outside of the graduated cylinder as the pressure of the gaseous mixture in there, and so that's why I have to have both of them equal. So I'm going to come on over here and read it. It's kind of hard sometimes to read it upside down and to the tenths, but we'll do our best. And it looks like to me it's right at 44.0. So 44.0 would be, and I'm reading it to the tenths, reading my graduated cylinder correctly. So that is going to be in milliliters.
So we filled that in right here on the data table. Volume of butane collected in milliliters is 44.0.
And then now I'm going to go back up and do that step 5. This is where if we had more than one of us getting our hands wet, Ms. Franklin has to film. So I'm shaking it out again. Remember to shake the mass of water out of that lighter and dry it really well. Don't want any water up in there. And zero my balance. And it has gone to 21.46. 21.46.
This is again also in grams. So that's our final mass of the butane lighter in grams, 21.46 that we filled in for trial 1. And then to find that mass of the butane released, if we started with 21.55 grams, we ended with 21.46 grams, then the mass of the butane that we collected there is actually just the difference between the two.
Which looks to be what, 0.0009, right?
55, yes, 09.
Which seems about right to me.
0.09 grams of butane collected.
Okay. And then now the other piece of data that we're going to need, this is going to be step number 7 on your lab handout. If you're looking at it, we need the temperature in degrees Celsius. We're just going to estimate to the tenths. And I'm seeing 21.0 degrees Celsius.
Okay, 21.0. All right, so again, filling that in on our data table, degrees Celsius for the temperature, 21.0.
Now it says step number 8, record the barometric pressure. Remember, the barometric pressure, because they were equal when I read the volume, is going to be the pressure of the gaseous mixture in here. And we look on our handy dandy barometer over there. I think this is super cool because you can see how it's bouncing around because gas particles from the air are hitting the barometer. But so we just picked the one that we see the most often, which I would say is a 754.0.
Yeah, it's right about in the middle.
Yeah, 754.0. And that is in mmHg. You can see it on the instrument when she put it up there.
And 754.0.
Okay.
Now, the next little piece of this, we grab that for me. The next little piece of this is the water vapor pressure, and water vapor pressure is really dependent on the temperature of the water, which we just took. We just figured out the temperature of the water is 21.0 degrees Celsius. So we need to figure out what is our water vapor pressure at 21.0 degrees C. So we have this handy dandy table, which hopefully you can see. So the idea is, I'm going to set this down, to find 21.0 degrees C. So we're looking for the temperature at 21.0 degrees Celsius, which is what our water temperature was. And you see that the pressure of that water vapor is 18.6 millimeters of mercury. Are we doing that equation with them right now or later? So I'm going to write down 18.6.
Just collect data now.
Okay, we're going to go over fill that in.
Show them how to get it right
The
now.
water vapor pressure in millimeters of mercury, 18.6. That was what we just got. In order to find the partial pressure of dry butane, we'll show you why this is after, but we're going to subtract the atmospheric pressure minus the water vapor pressure. So subtract water vapor pressure from the atmospheric pressure there, and that will give you the partial pressure of that dry butane, also measured in millimeters of mercury. All right, so now we're going to do trials 2 and 3 with you, but this time we're going to make you write down the measurements. We're not going to be writing them down on the data table for you. So hopefully you'll be able to see this. We might call out the volume for you.
So, but just as a reminder, that final mass of the butane lighter, that 21.46, that can be your starting mass on trial 2. You don't have to, you know, remeasure it. We're gonna assume that it was all fine to start with, and the final mass becomes the new starting mass. But now I do need to go back and fill my tube up, make sure I don't have any air bubbles in it. I see an air bubble. And go ahead and collect another sample.
All right, so we kind of paused and fast forwarded here, so you didn't have to watch us filling the entire graduated cylinder. But now we have it filled to approximately 45 milliliters. Now, are they going to be able to read this on here?
Be able to read it. So it's always kind of a little bit hard to read against that level. Can you see it, Miss Frankovic, or do I need to pull it on over?
It's tilted a little bit.
Okay.
I would say,
I think it's below 45, like it's 46 something.
I would say it's, oh wait, that's 45. That's about 46. It's about 47.0 actually.
Okay, let's go 47.0.
47.0. So we're not writing that down for you, but you're writing it down. I can drop that now that we got the volume.
So that is the volume of trial 2, and we're going to now get the final mass of trial 2.
There we go. There we go.
1.36, write it in the appropriate place. And then we're going to need, probably the temperature hasn't really changed unless my hot little hands have increased it. So I'm going to stay at still 21.0.
You can see the atmospheric pressure back there. I think if I'm pointing to it.
You can decide what you think that 10th place is bouncing around at.
And record that as your atmospheric pressure. And you said 21.0 for the temperature again?
Yeah, so your vapor pressure would be...
So again, there's 21.0 degrees Celsius again. There's your vapor pressure of water. Okay. All right, now for trial 3, we're going to do the same thing.
Remember that final mass on trial 2 can be your starting mass on trial 3. And here is my tube filled with water. I'll start collecting, and then I'm sure we'll pause it so that you don't have to watch me collect it all.
Well, maybe I'll go over to the equation.
Oh yeah, it is going. Okay, yeah, so Miss Frankovic's going to take you around the room.
So we're just going to come over here while she's filling that. And let's see if I can prop us up here. Okay, so we were talking about the partial pressures. All right, so that we saw that, what was the atmospheric pressure?
754.0.
Okay, so we saw that our atmospheric pressure was 754.0 millimeters of mercury.
You wrote 7.4.
Oh God. 754, right? And we saw that the vapor pressure of water, so the pressure of H2O,
was 18.6.
was 18.6 at 21.0 degrees C. Okay, so this is what we got from our data. Here's how we're figuring out the partial pressure of butane. So Dalton's law of partial pressures says that the total pressure overall is going to be equal to the individual partial pressures added together. In our system here of collecting the butane gas, that means that the total pressure here is the atmospheric pressure. So our atmospheric pressure is going to be equal to the partial pressure of water plus the partial pressure of the butane gas. All right, and that's what Ms. Thomas was demonstrating as she was collecting it. So if we know these two, then we know our pressure of the atmosphere, our atmospheric pressure, 754.0, is equal to the partial pressure of water, which we found to be 18.6, plus pressure of butane, the partial pressure of butane. So all we have to do to figure out what the partial pressure of butane is subtract 18.6 millimeters of mercury from both sides. All right, now I'll check my math that I did earlier. I don't think I did my math right. No, wait. Okay. 10, 4. What what?
You have 746.4.
It should be 736.4.
Okay.
All right. So that would be our partial pressure of the butane gas. All right, so we'll change that in our data table. We only do one shot here, so we're not refilming. So coming back over here to Miss Thomas.
Yep, who's got her sample. And I'll try to bring it on over.
See if we can get this here. So we're looking again, down on eye level, 45, 46, 47.
Thought I got it past 47 this time.
I would say it's about 47.9, almost 48.
Maybe
so,
go 48.0.
Yeah, about 48.0 milliliters will work for your volume.
Do my final shake out here and get the mass.
Wow, Krista with her math.
Oh dear, almost frank of it.
I really should have just put it into a calculator.
I really should have just.
All right, so
Okay.
here's our mass, our final mass reading for that butane lighter for trial 3, right? We're on trial 3.
Okay, yep.
All right.
And
Getting our temperature.
probably hasn't changed. I mean, maybe it's, yeah, I'm going to say it's still 21.0.
All right, which means our partial pressure of the water vapor is still 18.6. That hasn't changed. Okay, and we can look over here at the atmospheric pressure.
I think it's going up a little bit.
All right, so you should actually have a different atmospheric pressure for trial 3 when you get to this.
So,
Yeah, I'm not seeing 0 come up very often.
Yeah,
Okay,
so-
now back to the math really quick on trial 1. Here's the correct math. 754 minus 18.6 is going to give us 735.4. So I apologize, but you need to cross off the original and write in 735.4. All right, I
okay.
think that's it. All right, so you should be able to fill in the data table for trial 2 and 3 on your own. Okay, remembering that this mass of the butane is the difference in these two masses, the initial and the final. And the partial pressure of butane is the difference in these two pressures, according to Dalton's law. So, get your analysis questions going, and we will talk about this in class. And if you're not there, we'll have a video.
All right. See you later, kids. Bye.